Hello guys, today I come with a video about something that you're gonna see in CCNP. You actually do not see this kind of stuff um, in CCNA. The four modules that you take, you're not gonna see Mpls, uh, multi-protocol level switching. You're not gonna see this on those classes. So I just want to give you a quick review about this MPLS protocol, how to configure this, and how important and great is this protocol. First, I'm gonna read a couple of stuff so you can understand more or less what this is, what this protocol comprehend, and what this protocol is useful for. First off, I want to say that in a traditional environment, the routers in layer 3 switches, they handle routing. They're gonna handle routing. They need to look at IP routing table to forward a frame or forward a packet to the next hop or the next router. Usually, so far, I guess you have seen only routing table and how the routing table is in charge of, um, and how the router in the routing table is in charge of sending the packet to the next hop. Either you're using the protocol OSPF or EIGRP or BGP or ISIS. Any protocol, the routers are always gonna look at the routing table first in order to see what is the next neighbor, what is the next hop that they need to send the packet. Now, most of the time you're gonna see this kind of stuff in the routing tables, where there is an IP address prefix, there is a metric, there is a administrative distance, and there is the hour and the minutes, seconds that the route has been there, and also the interface that is gonna the interface which the route is gonna go through, right? So first off, before we go further, MPLS stands for multi-protocol level switching. Why level? Level is a keyword right here because level is basically something that is very useful in this protocol. What MPLS is going to do in this case is going to put a level in front of the packet, in front of the frame, and all other routers are going to do the same. They're going to put levels in front of each packet as the packet goes on every router. They look for their level forwarding table, and that level forwarding table will basically transfer that packet or pass the packet to another router, which in this case that router is going to look again into the level forwarding table, and the process is going to repeat on and on. So forth is going to be always the same. The routers are going to get the packet and sent, and the other router is gonna look under his level forwarding table and match up and send it to another router, which is gonna have a level table as well, level forwarding table, and is gonna this process is gonna repeat in this case. As you can see right here, for example, site A and site B. Site A Site A has a router right here, which level is 34. site B has another router right here, another right here. Could be a three more routers, or it doesn't matter the amount of routers. This there is another router right here with a level, and I put this example so I can explain how it works. Let's suppose a site A wants to send a packet to site B, and there are three routers like this along the path to get to site B, for the packet to get to site B. Router with the level of 34 is gonna send the packet to the router with the level of 55, which is this one right here. Now the router with the level of 55 has what we call the level forwarding table. That level forwarding table is basically this other cloud that I tried to draw right here. I've drawn this cloud right here so I can explain you that this is the forwarding table, the level forwarding table. Now there is an ingress and an egress. So as you can see, it's not looking in the IP routing table to get the packet through. It's looking at the cloud, and that cloud or that level forwarding table has an ingress, which is a 34, because that's basically coming from the 34, and egress or egress, sorry, which is a 55, and that's where the packet is gonna go to the next router or hop. As you can see, this router 55 is receiving under the 34 and is gonna send it to through the 55 via fast Ethernet 00. This other router right here might have a different level. It's gonna keep doing the same. But the main thing right here is that they are not looking at the routing table. Right here it says, and instead of looking at the routing table and prefixes and stuff, the router is going to forward that to the next router and the next and so forth. And then the process is going to repeat, as I said before. Now, when it comes to the final router, or when there are not going to be any more levels, what is going to happen is that at the end, there are not going to be any levels, because that's the final or the edge router right there, the one that is going to give an IP, I mean give the packet to a next specific with a next specific source IP to the destination IP. That router is gonna do something that is called pop. Is gonna pop it off and just stop the Mpls process right there, and the packet is gonna go through the routing table to its destination. I'll explain a little bit more of this when I get to the example right here. But pop means that that's the end of the packet along the MPLS process. At the end of the last router is gonna pop it off and give the packet or transfer the packet to the destination. Now, this protocol MPLS, it works in a 2.5 Aussie model. And why 2.5? Because it's right in the middle of layer 2 and layer 3. It doesn't go fully to the layer 2 and it doesn't go fully to layer 3. It's right in the middle and remains right there. Also, is not a replacement. MPLS is not a replacement of IP routing. MPLS is just a little bit faster and is an enhancement out of IP routing, and it works as far as in the router there is a CEF, Cisco Express Forwarding needs to be enabled in the router in order to uh, work with MPLS. CEF or Cisco Express Forwarding is already enabled in all the routers by default. You don't have to enable this or put some commands to enable. All routers come with this feature where CEF is already enabled. Also, it can carry unroutable stuff. MPLS can carry um, packets without affecting anything in the frame. The layer 3 frame is not going to be affected at all. Of course, it's less time. Quality of service is one of features. Also, it does traffic engineering, such thing that OSPF and maybe BGP or EIGRP doesn't do very often. It's very difficult to do traffic engineering when those protocols are established in a topology. MPLS basically actually knows what path is the best path before the router sends the packet. MPLS already know which route is the best to send that packet, and not having those loop in the network and choosing the best path for that packet. There are some terminologies. LSR, which means label switching router, is every single router that can do MPLS. So every single router is an LSR, level switching router. Now LSP is the whole entire path, or the all the routers involved in the topology that do MPLS. That's the path, the level switch path, and that could be any direction. And also there is the level edge router, which the level edge router is the one that pop off the last frame, so it can be reaching the destination. Is the routers in the level edge routers are the end routers at the end of the topology, the ones that connect the source and the destination. I'll explain a little bit more right here. And the routers in the middle also are part of level edge, well, are not part of level edge routers, but those are basically within the level switched path. They're in the routing IP routing protocol. They have basically two tables: the control plane and the data plane. The control plane is where the protocol itself is handled. In this specific case, EIGRP topology table is basically handling the control plane, and data plane, which carries IP routing table or IP routing information. The router is going to look into the IP routing table to forward the message or the packet, and it's not going to look into the control plane because the control plane only handles what the protocol is. When you enable MPLS, the control plane and the data plane, they basically redistribute in different tables, as you can see right here. Thanks to Cisco Express Forwarding, there is in the besides the IP routing, there is FIB. FIB stands for Forwarding Information Base. Also, there is the adjacency table. 。  . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 。 。 。 。 。 。 . 。 . 。 . 。 . 。 and LDP, which is the level distribution protocol, that creates the level information base. And those have different, basically, uh, they work in a different way. Each and every single one work in a different way. The level information base is for packets that are not leveled yet, so are basically going into the edge routers, the level edge routers, and they have to go to first the fib, the forward information base, so they can grab, they can put, the packet can basically obtain a level and then be transferred to the next level. And for those packets that are already leveled, they're gonna go to the leveled forwarding information base, which is for packets that are already leveled. So when MPLS is basically enabled and it doesn't have a, is the first packet entering the network, entering the MPLS network, they are gonna be frameless. I mean, the levelless. Like they will not have a level on or placed right there in the front of the frame. So they have to go to the fib, the level distribution protocol, to get a level, and then start basically the process of redistributing the levels across the network until it gets to its destination. So that's more or less theory about this. If you need this document, I can transfer this document to you. Just give your email in the comments below, and I'll just give you this and send you this by email. I will not put in the description because I just don't want to spread this information to everyone. I just want to share this information with people that really are willing to support and give good or seize the document. I don't want to transfer it to people that are not gonna care about the document. So therefore, I don't let this in the comments on the description below. Just send me your email and I'll transfer this to you, because that way I will see that you are interested in this information. Then you're gonna actually read it and you're gonna learn something from it. I'm gonna close this right here. Now I'm gonna start configuring this. All right. I have 6 routers right here, and I'm gonna start configuring the basic stuff like this links over here first. All right. Let's start with router 6. Let me see if I can open this. Okay. Configure terminal, interface, serial 30, IP address 10.0.10.2, 255, 255, 255, 252. That's 32. Okay. That's gonna go up, and then I'll just go with interface 030, IP address is gonna be 10.0.10.1. Okay, that's already settled right there, and I'm gonna configure at the same moment, same time, gigabit 10, IP address 150, 100, 12. This is gonna be 9. I'll shut down. And also in this router I'll configure a loopback interface, loopback 0 IP address. This is gonna be 1.1.1.255.255. This is 32. Shut down. I'll put it right here so I don't forget. I put a loopback right here. 2, 3, 4, 32. There's a loopback right there. And I'll start configuring this other side. Interface gigabit 10, IP address 150, 100, 12, 10, 5, 255, 255, 252. Now shut down. And now look how this is gonna change to up. And I'm gonna stop right here. Okay. I'm gonna configure another loopback for router 4. Interface loopback 0. IP address 222. Okay. This loopback is gonna be 32. Okay, there it goes. Now look what I'm gonna do right here. What I'm gonna do is now that this part of the topology is configured, I'm gonna configure OSPF protocol. OSPF. You can configure any protocol, even ISIS or BGP protocol, and the product and the Mpls is going to work with any protocol. Like, it doesn't matter which protocol is. What I'm going to do is I'm going to establish an OSPF process, which is going to be router OSPF 1. Do show IP route. Now I know I have network, which is a loopback, so I'm gonna put the loopback right here. Wildcard is all zeros. Area 0. Then I have network 10 0 10 0. This is gonna be like this, and area is gonna be 1. I'm gonna do this multi-area. And the last is the 150, 100, 102, 8. We already know is 30 in area 0. Okay, so now I have established all routes right here for SPF. I'm gonna do the same with router 6, router OSPF 1, network, and we put the only one that we have, which is this one, area 1. We should see any an adjacent coming anytime soon, and there it goes. There is an adjacent, so it means that R6 is able to ping the loopback interface and even the 150, 110, 102 network. Okay, and finally we're gonna put this exit do show IP route, show IP route. Okay, config T router OSPF 1. Oh no, I didn't want to do that. No, router OSPF 12. Sorry, it's router. Okay, now router OSPF 1 network. We're gonna put the network 2222, all zeros, area 0. We're gonna put the network 150, 100, 102, 8, all zeros, area area 0. Adjacent should be coming up soon, and there it goes. There's an adjacent. This router should now be able to ping the 10.0.10.0 network, and as you can see, the routing table is completely okay with the OSPF protocol. Again, this is not subject to the routing table as I mentioned, as I read before. I just want to show you I'm able to ping from R4 to R6, which I am by pinging 10.0.10 1, and by pinging 10.0.10 2, and R6 can do the same with the loopback interface that I put in R4. Now let's configure Mpls. First thing that I want to do is, okay, this side of the network is gonna, okay, this is an ANT router, right? This is what we called before the edge, the level edge router. LSR, level switched router, are basically all of them, because all of them are gonna do MPLS. But this is an edge router, and this other one right here is an edge. This R2 is an edge router. So I'm not gonna do MPLS on R6, and I'm not gonna do MPLS on R1, because I'm gonna assume that R1 and R6 are different companies and they are not ISPs. Something that I didn't mention is that MPLS works only with ISPs within the ISPs. Therefore, I put right here different type of cable. But these are basically just ISP internet service providers. This happens only within an internet service provider, since MPLS is an enhancement out of ATM or frame relay. Now, being said that, I'm gonna configure MPLS right here. First thing that we're gonna do is put the command MPLS IP. That will wake up MPLS, like that will tell the router enable MPLS. I'm gonna show run, and I'm gonna notice something right here. Let me look something real quick. Oh, you see it right here. IPsef. IPsef is already enabled. Okay, IPsef is already enabled, and therefore we can run MPLS. By default, I told you that IPsef needs to be enabled, and it's been enabled basically by default in all routers. Next thing that we will do is we're gonna configure an MPLS range. We're gonna put the levels right here. So we're gonna put MPLS level range. Why not only a single number? I don't want to put only a single number, because as many routers I have, there has to be a level for, okay, the amount of levels needs to match up with the amount of routers there are, meaning that for each router MPLS is going to work with, there has to be a level. So I'm gonna on R5, I'm gonna put right here that the level is gonna be from 200 to 250. That's gonna be its level. Now I'm gonna put that level in this interface gigabit 10. I'm gonna put right here IP, okay, MPLS IP. I'm gonna hit enter, and that's fine. I'm gonna do the same in R4, but I'm gonna create a different type of level right there. You will see MPLS IP, MPLS level, range. Also the range is gonna be from 300 to 350, and I'm gonna open up the interface gigabit 10, and I'm gonna put right here IP MPLS IP, hit enter, and there is gonna be an LDP, and an adjacent will be up. From this moment and forth, from this at this moment, the router are not gonna look anymore. R4 and R5 are not gonna look anymore for or to the routing table in order to learn what is the next hop. They're gonna look into the level distribution protocol right here, level distribution protocol, and into the level forwarding, level information forward in this case. Sorry, the level information base. Those two right here. They're gonna work with these two right here. For none level packets, they're gonna send it to the FIB. The FIB was the forwarding information base, and for things that are already leveled, they're gonna send it to the level information base in this case. Let me show you. Okay, now we have an adjacent form right here between R5 and R4. Now let me put right here the command. I'm gonna put right here the command show MPLS forwarding table. It's gonna tell me that it's gonna use a 200, and as you can see, I put the level range from 200 to 250. It's gonna use a 200 to reach the level 200 to reach the next hop, which is the loopback address for R4, and level the ingress level is 200. The egress level is pop, like I told you before. Why pop? Because there are no routers between R4 and the loopback 2222. Now let me show you. If I put the command show MPLS forwarding table, the range was 300 to 350. Now it's using the 300 to learn the 1111 loopback of R5, and the ingress is 300. The egress is pop also. Why is pop? Because it's basically right here. It doesn't have to go to a different level to get to the loopback interface. Now look at the 301 to reach 301 to reach the 10010 network. This network right here is also pop. The egress is also pop because this router doesn't have any type of MPLS configuration. Now I can continue on and on by putting right here another level. Like I can put right here 400 to 450 level in this router, and I can put right here 500 to 550. You put whatever you want, and at the end I will have a full configured MPLS only using MPLS routing forwarding information level information base, uh, and not looking at the routing table, and making the topology faster, and basically learning routes which are faster than others, comparing to IP routing or what IP routing does. Again, if you need this document right here, it will help you a lot. If you need, well, you can see the topology that I put right here. I only did this side because the topology is great. I mean, it's great, but also it's big. So I'm not gonna do this other part. I'll let you do this part and see if you can do it in your home, in your house. Packet Tracer does not support this, so you have to have GNS3 in order to work this out. I hope you enjoyed the video and you learned from this. And again, let me know if you need the document right here, and I'll send you the document besides any other documents that I found, and that way you can study this MPLS protocol a little bit more. I hope you enjoyed the video, and please hit like and subscribe if you can. Thank you.